All right, kiddos, so we are Unit 1, Day 3 now, still in Unit 1. And here's a look at our do now for Day 3. So number 1, pretty straightforward. Don't think too hard about that one. Number 2, pretty straightforward there also. So not to worry about anything there. I give you a little hint on number 2. Think of it as a number line. Okay, and that is the best way to think about it. A number line, we're starting here at point x1, going from 8 to point x2 over here to 12. And thinking of it that way is easily going to help you answer questions A and B. Moving on. So here's the essential questions we'll answer today. How do you calculate 1D distance? How do you calculate 1D midpoint? And of course, when I say 1D, I mean one-dimensional. Number 3, how do you calculate fractional distances? 4, how can distance be used to prove two lines are congruent? 5, how can they be used to prove two lines are parallel? We'll be able to answer all of those by the end of this video. Okay, so we're still Unit 1. Now we're getting into dimensionality and the quantification of space. And so dimensionality goes back to just, you've got one-dimensional planes, one-dimensional objects, right? So a one-dimensional plane would just be basically what we know as a number line or an x-axis, right? I shouldn't put a 1 there. Just an x-axis, okay? And we go either left or right to positive infinity to the right or negative infinity to the left, 0 being in the middle of it all, being literally nothing. And then you've got two-dimensional. You've got two-dimensional. Oh, and FYI, let's go back to one-dimensional really quick. So if I ask for a one-dimensional figure, there's only really, we can say there's two one-dimensional figures. A point is a one-dimensional figure, and so is a line or a line segment. Go ahead and write that out. Or what's known as a ray. Okay, a ray has a starting point, it has no end point. A line has no start or stop. A line segment has both a start and a stop. Okay, and of course, a coordinate plane, we number it, we give it meaning that way. Anyway, so back to two-dimensional. So you have two-dimensional planes, so the Cartesian coordinate plane, x and y, left, right, up, and down. Okay, two-dimensional figures are things like triangles, circles. That's a terrible circle, but you get the idea. All that kind of stuff, they're two-dimensional figures in two-dimensional coordinate planes. All right, and then we get into three-dimensional. So that's our spherical coordinate planes. Okay, and also our three-dimensional Cartesian coordinate plane, where we just throw in a z-axis, a third axis, and three-dimensional figures there. Well, that would be things like a cube or a rectangular prism, or again, a sphere, all that kind of stuff. Okay, so why do we need to quantify these things? Well, like we talked about when we talked about undefined terms, in order for us to begin to understand our own reality as it is, we need to start giving meaning to these undefined terms that we observe in nature, in space. Okay, so one of those ways that we give meaning to space, the simplest way, is distance. Okay, so here is little Johnny here at point A, and here is Bill over here at point B, right? Johnny and Bill obviously do not exist in the same point in space. And what our little human brains like to do is just determine things like how far apart are we, right? How long will it take to get from point A to point B? Well, that depends. How far is Johnny away from Bill? So something like distance really comes in handy here. All right, so first thing I need you to do If you want, go ahead and pause on this and just take a look at these steps and try to follow them through. So step 1, you're just going to take your ruler, and your ruler obviously is 12 inches, so you're just going to draw a ruler or a line that's the length of your ruler, right? So this is a 12-inch line that I've drawn. There's a 12-inch line that I've drawn. Okay, every inch, make a small vertical mark, so up and down. So here I've got a mark at 0 inches, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. Okay, and I spaced it out horribly. Of course, you're using a ruler. It's not going to look all terrible like this. All right, number your number line starting with 4. So over here at our starting point, we'll go ahead and start with a 4. And then 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Okay, so our number line goes all the way from 4 to 16. All right. So now I ask you the question. I ask you the question in inches. In inches, how far apart is 4, our starting point, from 16, our end point? So you could just count 1, 2, 3, 4, 5, or you could just use common sense. You're using a ruler. Every inch you made a mark. So obviously this distance, the distance between our starting point 4 and our end point 16, is going to be 12. Okay, that would be our distance, right? How far apart? So the next one, how far apart is 10 from 14? So now we're going here from 10 to 14. How far apart are those? Well, 1, 2, 3, 4. 4 inches, right? So we're at 12. Here we've got a distance of 4. All right, so now I'm asking you to renumber it. Now I'm asking you to renumber it. Erase all of this really quick. I'm asking you to renumber it starting from -7. So we're on number 6 now. So I'm at -7. All right. So remember, we're negative. We're counting back to 0. So -6, -5, -4, -3, -2, -1, 0, 1, 2, 3, 4, 5. All right. So how far apart? You're going to recognize this. How far apart is -7 from +5? Well, again, this is a 12-inch line that we drew, so our distance between the start and the finish is again 12. Oh, can't write. Meant to write a 12 there. Our distance there is 12. How far apart is -1 from 3? -1 from 3. Okay? It's going to be 1, 2, 3, 4. So our distance again is 4. Right? So these were the same little tick marks from before. We just have different numbers here, but this distance here is still just equal to 4 like it was the first time. Well, now we've got -5 from -2, so that one's a little bit new. So distance from -5 to -2, 1, 2, 3. So our distance there is 3. So I'm going to let you do this part on your own. Write a biconditional statement that will serve as our definition of distance. So if whatever your hypothesis is, then whatever your conclusion is, and again, this is about distance, one-dimensional distance. Okay, so I want you to come up with your own biconditional statement that will serve as a definition for distance. All right. So moving on, one-dimensional distance and the number line, the abstract definition of distance. Okay, so consider the following expressions. So basically, I'm asking you to simplify these. So 4 minus 16. 4 minus 16. So this is kryptonite to some kids. We're subtracting more than what's there, right? And basically, if we think of it as a number line, we're here at 4, and we're going to go 16 to the left because we're subtracting, so we're going to get 16 smaller. We're going to go 16 to the left. All right? Where that would end up is at negative 12. Okay? So that means 0 would be here somewhere. The distance from negative 12 to 0, well, that would be 12, right? And then the distance from 0 to 4, well, of course, that's 4. Therefore, 4 minus 16 is negative 12. All right? Or you could think of it, you've got $4 in the bank, and you spend $16. How much money do you owe the bank now? Because you spent more money than you had. Well, the answer there, obviously, is you would owe the bank $12. Okay, so that's another way to think of this. Let's look at the next problem. 10 minus 14. Well, that's going to be negative 4. And if you're having trouble with these and you weren't in class or you weren't on the Google Meet and you're just watching this video and I'm going a little too quick or not saying enough about these, because again, adding and subtracting positive and negative integers, it really messes with a lot of kids' heads. Shoot me an email or come to tutoring. I have it every day, Monday through Friday. All right? So anyway, negative 7 minus 5. So this is a little bit different. So I'm at negative 7. I'm subtracting, so I'm going left, meaning I'm getting 5. I almost said negative 5. I'm getting 5 smaller, so I'm going 5 to the left. Okay, so that's going to put me, I'm getting 5 more negative, right? So that's going to put me at negative 12. So I've got negative 12 there. All right, negative 1 minus 3, that would be negative 4. Negative 5, so this one has a double negative. Negative 5 minus negative 2, well, that's the same thing as negative 5 plus 2. Double negative gives us a positive. And the reason for that, what the negative sign means is the opposite, right? So the opposite of positive 2 is negative 2, and the opposite of the opposite, right? So the opposite of negative 2 is positive 2. So that's where I get negative 5 plus 2. Anyway, that's going to give me negative 3, right? So anything similar to what we did with the ruler and the number line that we drew. Anything similar. So let's try to relate that. So let's use our number line that we drew. So here we are at 4. Here we are at 16. Right? Or actually, I'm sorry. That shouldn't be 16. Here I am at, so our answer here, I don't know if I just didn't write it down or if I erased it, but our answer here was negative 12, right? So what we end up with, okay, if we count, just like we did on the number line, right? If I count back 16, okay, so negative 3, negative 2, negative 1, 0, or not negative, gosh dang it, 3, 2, 1, 0, and then negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, negative 7, 9, negative 10, negative 11. So I ran out of room. We'll call this negative 11. And this is negative 12 here. Okay, so that was 16 spaces there, right? It was just like what we did when we calculated distance. All right, negative 5 plus 2. So I'm at negative 5. And I'm adding 2, so that means I'm going 2 to the right or getting 2 bigger. So negative 5, negative 4, that puts me here at negative 3, right? I have a distance either way. of 2 between these two numbers, all right? So we're motivating a very simple premise here, okay? So when I've got two numbers, let's say I have an x1 and an x2. Okay, when I've got two numbers, say this is negative 3, this is positive 8. 0 would be in here somewhere, right? So basically what I've got is negative 3 minus 8, right? That would give me negative 11. And lo and behold, if I count, so the distance from negative 3 to 0, that's 3. The distance from 0 to positive 8, well, that's 8. 3 plus 8 gives me 11, so the distance would be 11. Okay, now notice when I measure distance, I don't have a negative, right? I don't have a negative. So what I end up doing is saying, well, I just want the order of magnitude. I just want the magnitude. And what I mean by magnitude is when you tell somebody how tall you are, right? You don't use negative numbers. When you say how far away Odessa is from Midland, you don't say it's, well, because it's going east, it's positive however many miles, right? I think it's like 15 miles. Okay, you just say it's about 15 miles, right? So the distance between negative 3 and 8 is simply 11, right? We wouldn't say that it's negative 11. We would just say it's 11. So we have an expression, an operator for that. It's called, if I can draw an arrow, it's called absolute value, right? So if you take your 2 points, so if we call this x1 is negative 3 and x2 is positive 8, if you take your 2 points and you say x1 minus x2's absolute value, that's going to give you your distance in one dimension every single time, right? So let's see if that's true or not. Let's try it again on another example. So let's try it on something simple. So let's say I want the distance between 4 and 15. I want the distance between 4 and 15. Well, you could just count. That kind of sucks, but you could do that, right? So our distance here would be 11. If we just count, our distance from 4 to 15 is 11. Or we can do it the easy way, and we can use our little formula we just came up with, x1 minus x2's absolute value. So we're going to call this x1, we're going to call this x2, we're just going to subtract, right? So let's go ahead and plug our numbers in. So x1 is 4 minus our x2, 15, and we're taking the absolute value, and that's going to give us our distance in one dimension, right? 4 minus 15, that's negative 11, right? And the absolute value of negative 11 is simply 11, okay? Now, why is the absolute value always positive? Well, let's talk about that real quick. So let's look at the two numbers 4 and negative 4. The absolute value of negative 4, the absolute value of negative 4 is 4, and the absolute value of 4 is also 4. Well, why is that? Well, that's because 4 is how far away from 0? Well, it's 4 away from 0. And so is negative 4. Negative 4 is also 4 away from 0. That's why these two numbers have the same absolute value, even though one's positive and one's negative. Anyway, I digress. Our formula for one-dimensional distance, is this guy right here. Okay, and I'm going to use D with a subscript of 1 to denote that this is one-dimensional distance. All right, this is super important. It needs to go in your notes. We're going to build a lot off of that. Okay, so now that we understand distance a little bit, we're going to go ahead and get into midpoint. So we've already been using common sense to do distance and midpoint. Okay, but now we're going to get into some uglier examples where it's not so simple, right? So let's look at our first example, number 1. So we're looking at x1 is 4 and x2 is 16. All right, so our midpoint our midpoint is this guy somewhere in the middle, right smack dab in the middle. That's our midpoint. We could use common sense like we have been. And go ahead and say, well, 4 and 16 are how far apart? If we use our distance formula, 4 minus 16, that would give me negative 12, and the absolute value of negative 12 is just 12, right? So our distance, therefore, our distance between x1 and x2 would just be 12, right? So now what is our midpoint? Well, this should be, our midpoint should be 6 away from x1 and 6 away from x2. So that means our midpoint is either 16 minus 6 or 4 plus 6. Either way, we arrive at our midpoint is 10. But there's another way that we can do this. We'll see if we can work a few examples using common sense and determine what our actual formula would be. So let's keep going with this. So we've got 10, we've got 14, right? Our midpoint's here in the middle. Okay, so we should have the same distance from M to x1 as M to x2, right? The total distance between these two is 4, right? And we get that, so just so you can see me work out another example. So 10 minus 14's absolute value is going to give me my one-dimensional distance. So 10 minus 14, that would be negative 4, and the absolute value, we just discussed that. That would simply be a distance of 4. Okay, so 4, so that means I've got to go 2 this way or 2 this way to be right smack dab in the middle here. So that means 10 plus 2 or 14 minus 2, that puts me at 12. Right, so you might start noticing a pattern. Let's do the rest of these. The pattern's not always so obvious. So negative 7 is our x1. Positive 5 is our x2. So what is our midpoint then? This one's a little more complicated. Now we have a negative and a positive. So our distance between x1 and x2 is going to be 12. Okay, so that means we've got to go back 6 or forward 6 if we're in the middle, right? Because the total distance is 12. Right, so that means our midpoint is 6 plus negative 7, because we're going to the right, or 6 minus positive 5. Either one of those puts us at negative 1. Okay, so our midpoint is negative 1. Now, common sense was kind of useful here, right? But when things start getting worse, okay, let's go ahead and try and generalize. Let's see if we have something. So, negative 1 was our midpoint. It was 6 away from the start and 6 away from the finish, right smack dab in the middle. Okay? We can actually, from this, start deriving a formula for this. So if I add our start and stop, negative 7 and 5, and I find half of that, I'm going to end up with negative 2 over 2, which would be, negative 1. So I calculated my midpoint doing some mathematical witchcraft here. Okay, so let's try it on number 4 and 5 and see if we get the answers that we should. Because common sense doesn't always serve us as well as pure just logic. So let's go ahead and try this out, see if it works. So I've got negative 1 is my x1, and positive 3 is my x2. Well, what is my midpoint now? So let's skip the common sense and let's just try the little formula that I did. So I just added the start and the stop, and found half of that. So negative 1 plus 3, that would give me positive 2 over 2, which would be 1. Now, let's see, using common sense now, if this is in fact the midpoint. So common sense says it should be the same distance from the midpoint to the end and from the midpoint to the beginning, right? So how far is negative 1 from positive 3? Well, our distance there in one dimension would be 4. Negative 1 minus 3's absolute value, that would be the absolute value of negative 4, which is just 4. Right, so that means I've got to go 2 back that way or 2 back this way. And we know that that's the case. Negative 1 is 2 away from positive 1. Positive 3 is 2 away from positive 1 also. So our little formula seems to work. Let's try it one more time and just double check. All right, so on to number 5. So we've got x1 is negative 5. And x2 is negative 2. Okay, so these two are only a distance of 3 apart. Right, so let's go ahead and try our little formula again. So negative 5 plus negative 2 over 2. That's going to give me negative 7 over 2. And if I wanted a mixed number, which I do, gives me an idea of where I'm at. So negative 3.5, aka negative 3.5. Okay, so that means my midpoint is supposed to be negative 3.5 or negative 3.5. All right, so let's use common sense for a second here. So the distance is 3, half of that is 1.5, so that means I'm going 1.5 in this direction and 1.5 in this direction, and that should put me right smack dab in the middle of x1 and x2. Now let's see if that's true or not. So negative 5, if I go 1.5 to the right from negative 5, well, yes, that's going to put me at negative 3.5. If I go 1.5 to the left of negative 2, that's going to put me precisely at negative 3.5. Yep. So our little formula works. So what is our formula? So our midpoint formula in one dimension, let me abbreviate a little bit, our midpoint formula in one dimension is simply you take your start point, you add it to your end point, and you divide your sum by 2. Okay, and that is not to be confused. We are not taking the distance and dividing by 2. No, that is no bueno. That is not the same thing. That is not the same thing. We are not dividing the distance by 2. All right, 2 completely different things. We're taking our start and we're adding it to our finish, and then we're just dividing all of that by 2. All right, that's how this formula works. Okay, so points at fractional distances. Points at fractional distances. So this one is a little bit more complicated. So we're going to see a few examples. It seems a little more complicated. Don't let me scare you when I say that, but it's really not. It's really not. So 3 and 39. So again, number line. x1, 3, x2, 39. What is our distance? What is our distance? And if you haven't already read the problem while you were watching me talk, I guess I should have read the problem. If x1 is 3 and x2 is 39, so that's where I redrew, what point lies 1/3 the distance between x1 and x2? So we're only going, so I divided our distance between the two into thirds. We're only going this far. I'm going to put a little 1/3 distance right there, right? So basically what we're going to want to do, just by looking at this, we're going to take our distance that we get between x1 and x2. We're going to figure out, well, what is 1/3 of it? And we're simply going to add that. We're simply going to add that to our start, right? So let's see if my little theory works. So I'm going to do 1/3 times the distance. So I need to calculate the distance. 3 minus 39's absolute value. And we're going to add that to our start point. 3. Okay, so our actual distance, 3 minus 39, that's going to leave me with negative 36. And the absolute value of that is just 36. Okay, if you don't remember how to multiply fractions and whole numbers, all you do is put the whole number over 1. The way you multiply fractions is just straight across, numerator times numerator, denominator times denominator. So 1 times 36 is 36, 3 times 1 is 3, 36 over 3 gives me 12, and then we're just going to add the plus 3. That's going to give me 15, right? So so let's use common sense here for a second. Is this true or is this false, right? So did my little theory work or not? So our total distance was 36, right? If we use common sense and we're only going 1/3 the distance, we're going 1/3 the distance instead of all the way, we're only going 1/3. Well, 1/3 of 36 is 12, so that means I would have gone 12 to the right, 12 to the right of 3. Well, 12 to the right of 3 is 12 plus 3, which is 15. So it looks like my theory panned out. So from this, we have a little generalization that gives us a formula. So if you're trying to calculate the fractional distance, if you're trying to calculate the point at a fractional distance from another point, all you need to do, so here's x1, here's x2, here's the point at some fraction of a distance, right? This is our fractional distance. Okay, you're literally just adding your fractional distance to your start point. Your fractional distance comes from you taking whatever fraction you're multiplying by times your actual distance itself. So this looks like some crazy, satanic algebra right here, but it's really not that bad. Oops, wrote the wrong number down. That should be a 1. What's wrong with me? Anyway, this is all we're doing. This would be our formula here, right? So let's try it on a few more examples and make sure that it works. So let's try it on this next one. Okay, so if x1 is negative 28 and x2 is 14, what point lies 3/7 the distance between x1 and x2? So let's go ahead and test my little formula theory out. So our fraction is 3/7. Our distance is going to be calculated by negative 28 minus 14's absolute value. And we're going to add to our starting point, which is negative 28. That's our x1. So just to reiterate, our fraction times the distance plus our start point. And that is exactly what I have here matched up. So let's go ahead and test this out, and then we'll use common sense to verify if I'm crazy or not. So our distance, negative 28 minus 14, that's going to give me negative 42, whose absolute value, of course, is then just 42. And then we're going to multiply that by 3/7. And again, to multiply a whole number and a fraction, you just put the whole number over 1. The way you multiply fractions is top times top, bottom times bottom. 3 times 42, that'd be 126. over 7, and then plus our starting point, negative 28. And you may want to go ahead and get a calculator for this one. I'm pretty sure that divides evenly. 126 over 7. Yep. We get 18 plus negative 28. If I'm adding a negative, that's the same thing as subtraction. So really what this is 18 minus 28. That's the same thing. So I'm going 28 to the left, right? So minus 28 is going to give me negative 10. Right? So let's try and use common sense here. So our total distance was 42, right? 1/7 of 42 is 6. 6 times 3, because it's 3/7. 6 times 3 was 18. 18 plus negative 28 puts me right at negative 10. So our formula works. I'll go ahead and leave example 3 for you to do on your own in your notes. And here is our exit for today. So here we have some guided practice that I want you to work on. You're going to do this here in class. Feel free and email me or whatever it is you got to do. If you're getting this from the video directly, come to tutoring if you need it. You need to be able to do this, and I need to see this in your notes. You're going to turn this in with your notes the same way you do your EQs. Same thing with the EQs. You got to get them done. Turn them in with your notes. So any questions, come through to tutoring and or shoot me an email.